Hello, good day mga idol. I am Angelo D. Alagos and a student from STEM 12-9. Today, we are presenting our lab experiment.
To illustrate the relationship of the variables of Ohm's law, we use the PhET simulator to create our own simple circuit so that we can plug in the values that we have on our table so that it may show us the difference between each trial. The only variable that we changed with each trial was the resistance. The voltage was kept constant throughout the entire experiment. For our first trial, we used a resistor with 20 ohms of resistance. Our battery's voltage was constantly 50 for all trials. For the first trial, we had a current of 2.50 amps. For the second trial, we used 30 ohms of resistance, and we had a current of 1.67 amps. For the third trial, we had a resistance of 40 ohms, and we had a current of 1.25 amps. For the fourth trial, 50 ohms, giving us a current of 1 amp, and the last, for 60 ohms, we had a current of 0.83 amps.
Hi, my name is Melcher Villaluna Jr. and I was assigned as a procedure in this laboratory experiment. And as we do this lab experiment, we use the circuit construction kit DC fit simulator, just like what Sir Monoso told us in the video, to know the result of resistance, current, and also volts. We use resistors to know how much resistance we get, and also the ammeters, which tells us how much current we got, and lastly the voltmeters to show on us how much volts we have. And for the theoretical voltage and theoretical current, we use the formula V is equals to I times R, or the voltage is equals to current times resistance for the theoretical voltage. And for the current, we use I is equals to V divided by R, or current is equals to volts times resistance for the theoretical current.
Hello, so today I'll be discussing our table in this experiment. There are 5 trials in which the resistance increases. The experimental voltage is a constant 50 volts. After using the PhET simulator, the experimental current is jotted down. The theoretical voltage and current is computed down below. Finding the theoretical voltage, the formula is theoretical voltage equals experimental current multiplied by resistance. Meanwhile, the theoretical current is equals to voltage divided by resistance. The computation part of our experiment is done this way. That is all. Thank you.
The main purpose of this activity is to verify the accuracy of Ohm's law principle. By doing so, the team was tasked to measure the voltage and current in 2 ways. Experimental current and voltage was measured through the PhET simulation, while the theoretical current and voltage was validated through Ohm's law principle with the formula V equals I times R. According to the data shown on our table, given that experimental voltage was constant and the resistance was increased at 5 trials, the current was decreased, and with that observation we can say that the relationship of voltage and current is inversely proportional. On the other side, experimental and theoretical ways of computing currents and volts shared the same results with a little to no difference at all. With that hypothesis, and testing we've conducted, we can say that Ohm's law principle is highly accurate to determine the voltage, current, and resistance of an active current.
Based on the data that we have acquired in conducting this laboratory activity, our observations have shown that the relationship between the voltage and the current is inversely proportional. Along with this, also to answer the objectives of this activity, we can give certainty and we can attest that the principle of Ohm's law, which in short, voltage is equivalent to current times resistance, applies to be legitimate in determining the voltage, the current, and the resistance of an active current.